Hello students, welcome to Learn Digital channel. We were discussing the basic concept of object-oriented programming from the book Object-Oriented Programming with C++. The author is Balagurusamy. So we are in the section 1.5, the basic concepts of object-oriented programming, where today we are going to discuss inheritance, polymorphism, dynamic binding, and message passing. What is inheritance? The concept inheritance is actually creating a class, new class with data and function actually from the existing classes. So these are actually we call base class, or we call parent class, so the properties of the base class will be inherited in the new class, and we will have a new class. As example, so we can say father, mother, and child. So in this case, the child is actually has come from father and mother. It's not directly a new class created, but inherited from these existing classes. So this concept is called inheritance, where we create new class from existing classes. Very simple concept, but it is very important in object-oriented programming to implement the concept of reusability, where in object-oriented programming the existing components we use repeatedly, we use again and again, and this is called reusability. We are actually reusing any class. Suppose this is a class A, we can create another class B, and this B class is inherited from the class A. So here I will say this is the base class and this is the derived class. So, or this is the parent class and this is the child class. So this is called inheritance, and there are different types of inheritance where based on the number of parent class we classify the types of inheritance in object-oriented programming, and we create new classes from existing classes. So when there is only one base class and there is only one derived class, we call single inheritance. And when there is more than one base class, and suppose it is A, it is B, and we are creating another class called C, so this is called multiple inheritance, where multiple base classes are used to create single base derived class. So here two and more class, not only two, it is not restricted to two only, we can use more classes from where the components or the we call function or data will be inherited in the derived class. This is called multiple inheritance. So likewise there are other types of inheritance we can discuss very easily. Suppose you want to create a new class, you want to create another new class from existing class, so we call it a hierarchical inheritance. Here class A is actually used to create class B and C. Here two derived class, two child class from parent class, or more than two, any number of classes can be created from a single base class, so or parent class. We call it hierarchical inheritance. And we have another type of inheritance here. This is called multi-level inheritance, where a class is used to create another class, and that derived class is used to create another derived class. So here class A is helping class B, and that B is helping class C. Here this is a level, we call it a multi-level, actually multi-level inheritance, multi-level inheritance. So this will go on if we want. So this concept is called multi-level inheritance. So in object-oriented programming, the concept inheritance means creating new classes from existing classes, inheriting the any class is actually having data and function. So in the new class, when we will create, it will be data and function. But suppose data 1 2 3, and here this 1 and 2 is actually inherited here. So 1 and 2 will come from class A to B. So here 1 and 2 has come from this, and it is having its own data 4 and function 1 2 3. So 1 and 2 is inherited 1 and 2, and it is having its own data. It's called 4, suppose. So this will be the new class created with the data members and member function inherited from its parent class or base class A, and its own class, its own. So a new class will be inherited data and function plus its own data plus function. It will be the collection of this thing. Very easy. So we can give one example. Let us give one example. So we have a mobile phone, mobile 1, mobile 2. So this is one class, this is another class. So this mobile 1 class is having some data and function, mobile 2 is having some data and function. Data and function, we refer data actually properties or the information which is actually describing the mobile 1. Suppose in this case, in mobile, the name of the mobile, the price, the color, the processor capability, the storage, there are many, the configuration of mobile phone. And here the another phone, mobile 1, mobile 2, these are used to create another mobile phone with new data and function, and some of the features which are inherited from mobile 1 and mobile 2. So here we call it mobile 3. So mobile 3 is actually created out of mobile 1 and mobile 2. So this is actually a real life example. We see when the mobile companies, they create new mobile, or they just launch a new mobile, actually that mobile inherits, or that mobile actually bears many of the qualities or properties of the previous version of that mobile phone, previous versions, and new features are also added. So it's a classic example of inheritance in case of automobile, in case of two-wheeler vehicle, bike. So bike 1 and bike 2 so can be used to create another bike called bike 3. So this will actually hold some of the properties from this, and some of the properties. Suppose this is the property D1, and here D2, and here D1 and D2 are inherited from this B1 and B2, and its own D3, its own data member or property new, and it is having some functions, 1 function 2 from B1 and B2, and its own function 3. So this way, this B3 will be a new class created out of this two base classes B1 and B2. So this is another classic example of inheritance. So likewise, parent and child, we gave example. Likewise, there are multiple examples. There are many examples you can refer to. You just try to find out where the inheritance is actually existing in our real life. So it will be better to understand the concept of inheritance. As I told, that object-oriented programming is nothing but the reflection of the real world objects and their relationship between them and the behavior which are there in real world. So this actually models the real world problem, and we have to find out the solution, and we have to model the solution with the objects in object oriented platform. So we discussed the inheritance and types. So this is actually an overview discussion of the different basic concepts of object oriented programming. We'll be discussing many other things and in details with programming, with practical later on. So for now, we are switching to another concept called polymorphism. What is polymorphism? The polymorphism means polymorphism. The polymorphism, the name, it poly means the meaning of poly means many, and morph means a form. So many form or many version or many form of any one particular thing. So any one particular thing is having multiple form. So this is many one thing is actually holding multiple forms. So this is the definition of object the polymorphism, where one component will hold multiple forms. So this is the definition of polymorphism. But let us again take one example. So you understood what is function. See, we have a function called add. So this add, when you call this add function from main, so you will specify the argument 2, 3. So here you are just sending 2 and 3 as integers. Okay, so here this integers, so means the structure of the function is like that: integer x comma integer suppose y. If you have any confusion with the function creation, so you go to the first second lecture, you will find I discussed about function, or you go to the lectures which I recorded on C, you will find the concept function there. So we create another temporary variable, suppose z. So z is equal to x plus y. So this is, we are just dealing with integer. So when you will do like that, add 2 comma 2.5 comma 3.5, here this 2.5 and 3.5 will not be entertained by this function, because here we are not dealing with float variables. So here what we will do, what is the solution to because see, the addition cannot be restricted up to integer, because you can anytime add float values also, but in your program is not supporting that, because you have only you are doing integer addition. So what you can do, you can have another function called add with the same name, but here you can do like that: float x comma float y, and in that you can add z is equal to, or float z is equal to x plus y. But now there will be no problem. See, add, when you call this function, it will actually call this. When you call this with integers, it will call this. So for integer, one version is there, and for float you have another version of add. So here the name is add, or function name is add, but it is having two versions. One version is for integer, another version is for this one, float. So we call same thing having multiple form, and it's a Greek word, so it is not an English word. So poly means many, and morph means form. So now you understood, and this is again an overview discussion. And see, this concept we call function overloading. It's a type of polymorphism, actually type of polymorphism here, function overloading. So this is one kind of polymorphism. We'll discuss about this overview class. I said we are actually in the first chapter of object-oriented programming. As I said, I will be referring the object-oriented programming with C++ book by Balagurusamy, because many of the students are there, those who actually face problem going through the book, because they have to face exams. So side by side I will be referring the book also. It will be better for that community, those who actually think in respect of exam. So this is another concept. So we'll go to the next section called dynamic binding. Here, this is again a kind of exam. It's not that it's a kind of advanced topic. Dynamic binding. So dynamic binding is an advanced is a advanced topic, and which will be covered in the subsequent classes. And again, I'm giving a little introduction to this. See, we discussed polymorphism, and we discussed that when you call add 2 comma 3, one version will be selected. When you call 2.5 comma 3.5, another version will be integer version will be selected. Or when you call 2.5 comma 3.5, you will float version of so these are actually done in compile time. Compile time binding means there is a main. So from main, you know which version to call at the time of compilation. So there is no runtime activity, because before you go to runtime, you just selected that add, suppose float version will be selected, already selected. So this is called early binding. Or static binding, or sometimes we call it compile time binding, and we call it compile time polymorphism. That is function overloading is example of a compile time polymorphism. But suppose you don't know a condition that at the time of compilation you don't know which version to select. This is another concept. We call it we call this virtual function concept. So it will come in terms of runtime polymorphism. So one is called compile time polymorphism, another is called runtime polymorphism. So in compile time polymorphism, the binding means selection of function, which version will be selected, it is done during the compilation. And in case of runtime polymorphism, at the time of compilation, it is not selected. It is not possible to select the correct version of function. So during the execution of the program, that version is actually selected, the required version. So that we call it late binding. We call it late binding or dynamic binding. So we will discuss about this virtual function later when we will discuss runtime polymorphism. So for the time being, we are not going forward with this topic. So another thing here, the concept, today's topic is message passing. Message passing means communication between two objects. Here is one object, another is another object. So for the timing, you understand that if there is a requirement of communicating or transmitting information from one object to another, communicating, so that will be done So messages, so we call it a message passing. So we'll discuss this concept later. This is again kind of advanced topic, so I'll be covering this in the subsequent classes. So today we covered the basic concepts of object-oriented programming, and in the book you will find then they discussed what is object, already discussed what is class, they discussed, and after the data abstraction we already discussed. The data abstraction is hiding the details, the car example I've already given in the previous lectures, that the data abstraction. I'll be recording a separate lecture on data abstraction later, because it's a very beautiful concept, but you need to understand, because many of the students, they have confusion. They cover the whole syllabus, they cover the complete the course, but they don't understand the fundamental concept of data abstraction. Then inheritance, I discussed a little about inheritance, then polymorphism, then dynamic binding. What I discussed, that at the time of running, the selection of function will be done. What I discussed is written there, so in detail it will be discussed while discussing the runtime polymorphism, virtual function. So message passing, again this will be discussed in a very elaborate manner. So now there's a concept, there is a topic called benefits of object-oriented programming, so you can go through in the book, because I already discussed the advantage. So they have written many of the things in a very formal way. For exam point of view, you can write those things in exam, but it is better to write in your own way without changing the context, without changing the whole answer. You can stick to the point and you can write in your own language, and that will be better. But if you have any problem, so you can directly write those things, because these are the things which come in exams. What is that, benefits of object-oriented programming, advantage of object-oriented programming, features of object-oriented programming, the basic concept of object-oriented programming. So first chapter is actually all about this, so I'm not further taking any time that in this chapter. So here another concept is object-oriented language, means the languages which actually built on the concept of object-oriented programming methodology, and implementing all these concepts of object-oriented programming. It's called object-oriented programming languages. So C++ is example object-oriented programming language, and Java is another. So another example, there is a chart in this book, you'll find Simula, then Smalltalk, Objective-C, then C++, Ada, then Object, Pascal, Turbo, Eiffel, Java. Many programming languages are mentioned here as object-oriented programming, and different features which is available in which programming language are given in the form of a table. So application of object-oriented programming, you just go through, because self-study and self-development is very important, because these are these are the thing which need not to be discussed as overall concept I have discussed. So this is the first chapter, so I will say chapter 1 completed. So you go through the video again and again. If you have problem, if you have any sort of query up to this, you just comment below. I will just try to sort all these things in the next videos if you put your query. So what I discussed till now is actually about the object-oriented programming as a whole overview, and I discussed many concepts which are related to object-oriented programming. So from now I will be doing practicals with object-oriented programming language C++, and I will be covering all the concepts which we discussed as an overview. We will discuss in details, and will give many examples as programs or as real life examples. Thank you.